Hello everyone, welcome to Mechanical Software Education channel. In this video, we are going to learn about the stress analysis of a 11-bar truss element by using Ansys. Look at this drawing. You can see here the points are pinned and also roller support is there, and 11 bars should be connected each other, and the dimensions are given in meter, and the downward forces from point B, C and D is an equal load. It is acting in downward direction, that is 5 kilonewton, and the nodal points are given here. So point number A as 0, 0, so depends on the dimension, depends on the length and also the height. We can easily give the nodal points of A as 0, 0, and F point as 0, 3, and B point as 2, 0, and again C as 4, 0, D as 6, 0. Up to here we just calculated A, B, C and D, and you can easily find point E, that is it is almost the height is 3 meter, so assume that it should be of half of this 3 meter, that is 1.5 meter, so the length is 4, 1.5, so that is the point of E. And you can go for F and G. F should be 0, 3, and G it should be 2, 3. So with the help of these data, we can easily draw this 11-bar truss element, okay, with the help of link 180 material. Okay, the extra input data we are going to give is Young's modulus value, area, and also the Poisson's ratio. So here all the units we are going to use is meter. Okay, so with the help of these data, we can easily draw the truss element by using Ansys. Let me move on to Ansys. Starting from here, it should be of preferences, structural, preprocessor, element type, add your element. We just chose a link 3D finite strain 180, that is link 180. So the explanation is there in the previous video for link 180. And now go to material properties, choose the material model, linear, elastic, isotropic. You can check here 2E11, okay, and the Poisson's ratio is 0.33. You can check. So 2E11, just click here, 2E11 and 0.33 as the Poisson's ratio, and give OK and close here. And now go to sections. In this section you just give a link, add the link, and the ID we can give as 1, give OK, and make sure it is L. I just use L here. No need to give L1, L2, L3 up to L11 because we have 11 links here. We need to create 11 links, and the area for each and every link is same, so no need to go for L1, L2 and apply L2 and apply L3 and apply. So likewise you don't go for like that, so just fix L as common, and here all the links having the same area. So here you can see here, see this area is 2500 mm square, that is 2500 into 10 to the power of minus 6. We can give this area here 2500, you can give here 2500 E minus 6 in meter, that is meter square. So give OK. So commonly we are using a single link, single data for making or considering as all the links should be having the same area. Okay, then you just model your drawing with the help of create the nodes inactive coordinate system. So inactive coordinate system, you can see here with the help of this nodal points, you can give the first nodal point as 0, 0 and give apply. The second nodal point, it should be taken as B, 2, 0, give apply, and the third nodal point, it should be of C, 4, 0, give apply, and the fourth nodal point give 6, 0 and give apply, and the fifth nodal point, that is 4, 1.5 here, give apply, and the sixth nodal point I'm going to take as F, that is 0, 3, give apply, and the last one, that is G point, that is 2, 0, sorry, 2, 3. So that's the coordinates. We just created the nodes. So with the help of these nodes, we can easily join with the help of elements. Okay. So now we just go for elements and go to element attributes. We can check here. We just chose link 180, and the material we just chose only one material here. We didn't go for any different type of materials. That's why the material number is given as 1, and the coordinate system is not required. And the section, we just use the L as our section, and we gave the area value as 2500 E minus 6. Okay, so use give OK here, and now give auto numbered through nodes. So we just created nodes, and with the help of through nodes, we can create the lines. Okay, this is the line called as elements. Okay, now give apply, and now starting from here to here, so we need to join each and every node here. Okay, so very simple. So we can easily connect it with the help of through nodes. Okay, so we just created all the elements. In this problem, in this stress problem, while we go for nodes or even element attributes or auto number through nodes, we shouldn't go for any meshing region, because we already created the node and also elements. Here you have only one element and two nodes are there. Okay, so don't go for dividing the elements into number of divisions and likewise. Okay, so now go to a solution. In this solution, just go for define loads, apply, structural, in displacement. We need to go for arresting this sixth node and also the first node. Actually, in the sixth node, it is fixed, or the all degrees of freedom should be getting arrested in the sixth node. You can check here. Here you can see here the fifth point, sorry, the F point. F point is nothing but the sixth node. The sixth node is getting arrested. Actually, in the in the first nodal point, that is A point, it is a roller support. So roller support means it should be acting in a downward direction. It should be acting in the downward direction. That should be of Y, and you need to arrest in X direction. You need to arrest X direction, so allow the truss should be moved in a Y direction. Okay, so with the help of this one, you can arrest sixth node and give apply, and go to all degrees of freedom, and it is a fixed one. Okay, now in the same node, in the first node, you just give click on that first node and go to OK. And in this part, so it is a roller support in a Y direction, so just arrest X direction alone. Okay, so now you need to give some force or moment. So force or moment at on nodes, second node, third node and fourth node. So these three nodes having a downward load of 5 kilonewton. So give OK, and select Fy. It is in a downward direction, so 5000. So 5 kilonewton. So minus stands for a downward direction in in Y. So give OK. So we already completed the boundary conditions for this truss element or truss problem, and go to solve, go to current load step, give OK. Just wait for a while. Okay, the solution is done. So we can also check the analysis type. It is a static, so no need to worry about that. Okay, so static one, no problem. Okay, then we need to go and check the results. Plot results. We can check the deform shape first. In this deform shape, you can see the entire deformation happens on the 11 board truss element. Actually, in the top region 6th point, the entire stress should be maximum in this region because it is a fixed. And here you can see the normal position of the bar is here, and just the deformation happens below the normal position, so it should be moved in y direction. Okay, so now give contour plot and nodal solution, degrees of freedom solution, and displacement vector sum, or even x, y, z. You can take values only for x or only for y or even z, or I just chose displacement vector sum. It is a combination of x, y, z, and that's a maximum value for the displacement. Okay, so it is the exact displacement for this truss element. So now we just go for style, size and shape, and just on the display of elements. This is the exact display of elements in 3-dimensional. Likewise, just see here, and now you just check the stresses. I just go for one measure stress. The stresses is maximum in this region. So if you want to check with animation in a deformed result, go to stress, in one measures, give OK. Now you can easily understand where the stress is maximum in this region, or in this bar, or in this link, the stress is maximum. Okay, so just go to stop and cancel here. And if you want to get results, you can go for list results, or in nodal solution, and degrees of solution, degrees of freedom. Here you can see x component. If you want to check the x component alone, you can go for x component. So here you can see 7 nodes are there. We created 7 nodes, and each and every node having the values except 1 and 6. 1 is just an starting point, that is origin 0, 0. Here we just take only x direction alone. Okay, so even if you took if you want to take the value from y direction, so the 6th node having some value, but node number 1 is was getting arrested, so the value is 0. So all the dimensions are in meter, so the entire dimensions in this displacement must be in a meter. So just go to nodal solution, check with the y displacement. I can see here. Here also the value of sixth point is 0. So here you can see 6th point is nothing but the top region. We arrested the entire component or all degrees of freedom in this region. That's why in the y is also 0. So we can see here in the point number 1, the value is minus 0.900 e minus 4 in meters. Okay, so with these variations we can also check the stress value in 1 measure stress. Go to OK. Now we can check for 7 nodes. We just created 7 nodes. Node number 1, 2, 3 having a 0 in this region for a secondary region, and for third region you can check sigma 1, sigma 2, sigma 3, and sigma 4, sigma 5, sigma 6, and sigma 7. All the values are here, and the units what we are going to use is Newton per meter square. So to validate your result, you must go for numerical solution to with the help of a matrix formulation. We can get the values, and you can compare with the analytical solution. Now we just go for element table, define table to find the load step here, and just go for stress, by sequence number. In this load step you just give 1. So 1 stands for the node acting in the I direction. I direction means it is a starting point, that is starting from x. Likewise, give apply, and by sequence number load step it is given as 2. So 2 stands for jth node, and give OK. So 1 and 2, we selected 1 and 2. So now go to plot results, contour plot, line element results, go to I node as 1 and j node as 2. Give OK. So this is the maximum stresses acting in the particular region. So this is the bar or the link having the maximum load or the maximum stress, sorry, it is having the maximum stress here. Okay, so that's all for today's class. Actually, if you have any doubt about this truss element, you can post your comments or your doubts in comment box. So thank you very much. If you really gain more knowledge about this truss element video, press like and comment, subscribe my channel and support me. Thank you very much.